Hello, 5th grade math students. This is Chapter 7.4, Ratio in Fraction Form. In this lesson, we'll learn to interpret ratios that are given in fraction form, and we'll learn how to write ratios in fraction form to find how many times as large as one number another number is. Let's start. Let's explore how ratios can be written in fraction form. Let's say that Jason has two colored pencils, one red and the other blue. The ratio of the length of the red pencil to the length of the blue pencil is as represented in this model. The length of the red pencil is 3 units long, and the length of the blue pencil is 5 units long. So the total number of units is 8. All right, so the ratio of the length of the red pencil to the length of the blue pencil would be written as 3 to 5, right? The same ratio could also be written as a fraction. We would write it in this way, 3 over 5. So essentially, the first number, the first term in our ratio, becomes our numerator. And the second term in our ratio becomes the denominator. Remember, fractions and ratios are both simply ways to express relationships between numbers. So all we're doing is writing the same information in a slightly different format. Now let's write the ratio of the length of the blue pencil to the length of the red pencil. That would be written as 5 to 3. We could also write that ratio in fraction form by putting the length of the blue pencil over the length of the red pencil, or creating a fraction that says 5/3. 5 to 3 and 5 over 3 is the same relationship. Finally, let's look at the ratio of the length of the red pencil to the total length of the two pencils. If we were to write the ratio of the red pencil to the total length of the two pencils together, that would be 3 to 8. Now we could write that same ratio in fraction form by writing 3/8, the length of the red pencil over the total length of the two pencils. Here are two practice problems for you. Our picture shows us that Sam's height is 5 units and Jean's height is 6 units. Question 1 asks you to write the ratio of Sam's height to Jean's height, first in ratio form and then in fraction form. Question 2 asks you to write the ratio of Sam's height to the total height of both boys, first in ratio form and then in fraction form. Press pause while you work, and we'll come back to a new idea when you're finished. Another reason it's useful to write ratios in fraction form is that it can help us to find out how many times as large as one number another number is. Let's work through this example. The number of adults and children watching a show are as represented in this model. Adults equals 4, children equals 12. So how many times the number of children is the number of adults? Okay, so we want to begin by writing a ratio of adults to children, which would be 4 to 12. Now we can write that in fraction form by making our first term the numerator and our second term the denominator, giving us 4/12. We can reduce this fraction to 1/3. So our answer is the number of adults is 1/3 times the number of children. Notice the little oddity in the way this is phrased. The question asked how many times the number of children is the number of adults. But notice when we wrote our ratio, we wrote adults first. So when the question is asked that way, how many times the number of children is the number of adults, the second word becomes your first term, and the first word becomes your second term. So let's look at the other direction here. How many times the number of adults is the number of children? Okay, so how many times the number of adults is the number of children? So we want to know how many children compared to adults. So we'll put children first, adults second. I know that seems backwards, but that's the way it works. So we'll write our ratio as 12 to 4, which can be rewritten as a fraction. Our first term becomes our numerator. Our second term becomes our denominator. We reduce to get 3. The number of children is 3 times the number of adults. And we can just look at our original numbers and see that that's true, right? 4 times 3 equals 12. Just as we can look at our original numbers for the how many times the number of children is the number of adults, our answer there was 1/3. We can automatically see that there's 1/3 the number of adults as there are of children. 4 is 1/3 of 12. Okay? This is a little tricky just because of the wording, but I know you can get it. Okay, try one of these tricky ones on your own. Felice spent $21. Brad spent $42. In question 3, calculate how many times the amount Felice spent is the amount that Brad spent. Remember, whichever name comes second is your first term. Whichever name comes first is your second term. In question 4, calculate how many times the amount Brad spent is the amount Felice spent. Don't forget to reduce your fractions to give your answer in simplest form. Press pause while you work, and there's one final idea in this lesson. And here we are at the last idea for Chapter 7.4. We're going to learn to draw a model to represent a ratio given in fraction form. So we'll begin with this fact. Steve saved 3/4 as much as China. So Steve's savings would be 3. And China's savings would be 4. Now how do I know which is which? Because Steve saved 3/4 as much as China. So his amount is 3/4 of her amount. In ratio form, we would say that he has 3 units to her 4 units. Okay? So the total number of units would be 7, correct? All right. So if you were asked to write the ratio of China's savings to Steve's savings, you would write China to Steve would be 4 to 3 or 4/3. If you were asked to write the ratio of Steve's savings to China's savings, you'd write 3 to 4 or 3/4. Okay, see how that works? Finally, if you wanted to write a ratio for either Steve or China's money compared to the total amount that they have saved, you would take, say, Steve's amount to the total would be 3 to 7, and China's amount compared to the total would be 4 to 7, because we have 7 units total. Let's move on to the practice problems to close out this particular chapter. Here are your final 2 practice problems for this lesson. Ryan cut a rope in 2 pieces. The length of the first piece was 4/7 the length of the second. Draw a model to help you visualize how this will work. Remember, the first piece will be 4 units long because the first piece was 4/7 the length of the second. So the first piece was 4 units long to the second piece's 7 units long. Then write the ratio of the second piece to the first piece to answer question 5. And in question 6, write the ratio of the second piece to the total length of both pieces. That finishes up our lesson for today. When I see you tomorrow, we'll do more work with expressing ratios as fractions. See you then.